FastMCP 3 employs a URI-templated resource decorator to establish dynamic endpoint routing, where parameterized path segments enable runtime resolution of resource identifiers. This pattern leverages Python's type annotations and docstring conventions to create self-documenting, discoverable components within the framework's filesystem-based provider architecture. We're about to examine how a single function decorated with @resource can expose a RESTful interface, where the URI template userid becomes a variable parameter that maps directly to the function's argument signature. The implementation demonstrates FastMCP's convention for creating resource templates that automatically handle path parameter extraction and type validation. From FastMCP resources, import resource. @resource users //user ID /profile. Def get user profile user ID. SDR. Get a user's profile by ID. Return FID. Userid name. User. This code demonstrates FastMCP 3's resource function pattern with dynamic URI parameters. The @resource decorator registers a function as a resource endpoint, where the URI template users //user ID /profile defines a dynamic path parameter. When a request matches this pattern, FastMCP extracts the userid from the URI and passes it as an argument to the function. This approach enables RESTful resource modeling without explicit routing logic, as the framework handles parameter extraction and injection automatically. The implementation uses Python type hints for parameter and return value declarations, which FastMCP leverages for runtime validation and documentation generation. The function returns a simple JSON string, though in production you'd typically use proper serialization. This pattern is particularly useful for building API endpoints, where the resource structure maps cleanly to URI paths, though it does create tight coupling between function signatures and URI templates. The trade-off is between declarative simplicity and flexibility. Complex routing logic would require additional abstraction layers. Let's break it down line by line. From FastMCP resources, import resource. Imports the resource class from the FastMCP resources module, providing access to FastMCP's resource management capabilities for this code segment. @resource users //user ID /profile. Def get user profile user ID. SDR. Get a user's profile by ID. Defines a resource endpoint at the path users //user ID /profile that maps to the function getUserProfile, which takes a userid string parameter and returns a string. The decorator marks this function as a FastMCP resource that will be exposed via MCP with the function name as its tool name, since no explicit name parameter is provided. Return FID. Userid name. User. Returns a formatted string containing a JSON object with two fields: id, set to the value of userid, and name, set to the static string user. The outer single quotes create a Python string literal, while the inner double quotes are part of the JSON structure. FastMCP 3's URI-templated resource decorator creates a direct mapping between URI paths and function signatures, where dynamic segments like userid become function parameters. The @resource decorator handles the heavy lifting, extracting path parameters, validating types via Python annotations, and exposing the function as a discoverable RESTful endpoint. This declarative approach trades some routing flexibility for simplicity, as the URI template and function signature become tightly coupled. The framework's use of type hints and docstrings ensures self-documenting components, while the filesystem-based provider architecture keeps the implementation clean and convention-driven. In essence, you're defining RESTful interfaces with minimal boilerplate, letting FastMCP manage the plumbing between HTTP paths and Python functions.
decorator conjures profiles from silence, but names drift in after the echoes fade.